everyone. Good to be back. Yep. Don't move.
That's fun. Let's restart that.
I think my machine's cursed.
I think the HDMI cable's dodgy. Give us a second.
Okay.
Tell a joke, Amy.
Tell a joke.
What are those things at the top?
What are those things up the top? It's all from My Little Pony, and I've forgotten the names of the different characters, so sorry.
Nope.
Nope. Okay.
When in doubt, go for the big cable.
Yep.
Too big. There we go.
Hey, success.
Nope.
Nope.
Sorry.
Roll with it.
I think we have to, yeah.
Okay, we're rolling with it. So, charts. Charts are this hugely, immensely wonderful way of representing data in your apps. And if you've been around CocoaHeads in the past, you've probably heard a couple of different variations of me struggling through how I address presenting a lot of data. So now that Apple has come out with their version of a charting framework, I thought it would be worthwhile taking a look at how can I switch out my attempt for what Apple has and sort of see where can I go with what they have provided. Okay, so stepping back into the world of iOS 15, macOS 12 and before, these are pretty much the different parts that you need in order to put together a graph. So you need a Z-stack, you put the Z-stack in a scroll view, you then have a canvas for doing all of your drawing, you use a path to do the drawing in the canvas, and then you have some overlays to position a few elements like bits of text or axes, any sort of call-outs like that. So, doing this approach, what happens? Well, if you're dealing with a lot of data, you're drawing a lot of you're drawing a lot of points very, very close together. So, if you're dealing with, say, an iPhone mini, the points of difference are just pretty much, you can't see them, but iOS in your app is still going through the process of drawing all of them at that time. So performance is a huge issue that you need to work with. You also have maintenance. You're maintaining this code. You're having to do updates, bug fixes all by yourself. You may or may not be in a team. Extensibility, again, you are going to be, you need to write all of the changes yourself. If you're wanting to put a different style, a different spin on your charts and your graphs, then this is what you need to do. And you also need to think through reusability as well as usability. So if you're taking a graph in one context, how do you then present it in another? Now, there are a couple of solutions. You can throw out what you've got. You can introduce a third-party framework. You can keep going with what you have because third-party frameworks are their own pile of hurt. Or you can even just abandon the app and go, yeah, fun was had, but not really any of these make sense in the long term. Then along comes Swift Charts. So this is Apple's solution. It is available in iOS 16, macOS 13, latest, well, the upcoming tvOS and watchOS as well. So it is something that Apple has put a lot of effort into. They have made it insanely extensible, and the API is really, really nice. It makes a lot of use of SwiftUI conventions and is just a lot of great fun to be able to interact with. So, story from WWDC is I was over there in San Jose, in Cupertino, enjoying the sun and the fun times at Apple Park for their Day at Apple Park event. Thanks, Apple. And sitting there with laptop out, having just done the YOLO, update everything to the first beta. People that know me know that that's going to happen. So, laptop out, watching State of the Union, they were talking about Swift Charts. I was like, okay, how long is this going to take to get me up and going? It took me about 5 minutes to just throw out all of my old stuff and get a representation going with, with Apple's new framework, which is actually pretty amazing. I like throwing away code. It's the best type of code. So let's take a look at how you can go about building a chart. So we're just going to take a basic chart here. We've got a whole heap of data points, which for the sake of this, I'm not going to go into how you extract them and do all of that. It's just a series of X and Y points between some different ranges. So you throw it all into a chart and you say, hey, present this thing as a line graph, and this is what you come up with. Pretty good for just about 5 or 6 lines of code. Now, can we improve this? Having like 0, 10, 20 and so on the x-axis for your points doesn't really make much benefit. What you want is to actually tell your users what those values mean. In this case, they are distance points in a particular ride being represented, so they're kilometres. How do you then take your data and show it like this? Apple gives us these x-axis and y-axis marks, which you can present. So if you've got a value there, you then go, okay, draw a grid line. You can put a tick there, which is your vertical line going up, and you can also provide an appropriate label for it. So here I'm using helper function that I've defined to sort of take your raw value and apply the unit of measurement to it. If it doesn't actually give us a value we can use, we just say, okay, draw a grid line. Starting to look a little bit better, but I think we can keep improving. So what we're doing now is there's a different initializer for your axis mark, which allows to say, here are the points that we want to display. So using some logic, I'm going, okay, give me a certain number of points. And instead of having a rounding up to a value that appears at the end, we're just going, okay, we don't want to round that last value. We just want to cut it off because this makes our data look a little bit nicer. We can then do the same for our y-axis. So instead of having a raw value there, we then put in the particular unit and show the user what it is representing. As this is a representation of speed based at a point of distance, you've got kilometres per hour and you've got kilometres. Now, that's all good, just to have a wavy line, but we can make it a bit visually nicer. So let's put an area mark underneath it. What the area mark does is it draws that sort of filled in solid bit right there. Again, just provide it with your X and your Y values and say, hey, here's the colour that you want to be drawing it in. In this case, same colour, just with a fair bit of, well, it's not solid. So we've got our graph showing there, which is pretty straightforward and pretty easy. Let's keep going. What happens if we want to make this graph interactive? So with Swift Charts, we have a function that can be called, which is our chart overlay, and for that we can get our points of interaction. So to do this, we get Geometry Reader. This is one of the few areas where Geometry Reader actually makes sense, because we need to know the different areas between that the graph is filling as far as your, as far as the size of the graph, that's important. So we'll get to that in a bit, but we grab our Geometry Reader. Because we're dealing with an overlay, we then look at the entire rectangle that is there. Well, we want to put something over everything. So we use a rectangle, we make it clear, we make sure that the shape of it is a rectangle as well. And then we set up some tap gestures. So we're using a spatial tap gesture, which is new in iOS 16 and macOS 13, which gives us our coordinate point when we do a tap. So here we're going, okay, primarily we're after that tap. When that tap has ended, we want to grab our value. Using our different proxies, we then do our calculations to give us the point on the graph that we are interested in. You've also then got we want to make it a little bit fancier so that when you go along, you can actually drag your finger and it will follow your finger with those points. So we do the tap first, and then it's exclusively before any drag. So here, same calculations, we're just getting the same value and calculating it. How do we then do that with our particular code? Fairly straightforward. So we've got our point here. We get the X position, so the position on the graph relative to everything. Here we use the geometry and the chart proxies to accomplish that. We then use the chart proxy to get our X and Y values. Now, because what the chart proxy gives us back may not map directly to our data, we then want to look through our data and go, okay, give me the first point that is greater than here. That tends to work fairly well. And we save it off to some object that we can then use in our UI. In order to draw it, here we know that that can be nil, so we first grab the unwrapped version and we go, okay, just give us a bar mark. So we do that. For the image there, that's the the vertical line you see there. So we provided an X position. Start and end are pretty much the top and bottom of your line, and you've also got the width. So here it is a fairly thin line because we're wanting to call out a particular point. Okay, looks good, but it's really only showing our X value rather than both the X and the Y values. We can then improve that by doing a point mark as well, which will give us something that we can interact with at a particular point. So here, X and Y values we feed into the point mark, we give it some styling, we say just draw a circle of an appropriate size. Cool, awesome. That is how straightforward and easy it is to get a very nice interactive graph going in Swift charts. Now, as I alluded to before, performance matters. If you've got, say, a ride that has gone on for a couple of hours, maybe upwards of 100 kilometres in distance, lots of elevation gain, usual stuff that cyclists do, and then you're showing on a particular screen, you've got your speed, your elevation, your heart rate, your cadence, and a few other things going on. Well, that's going to make it a performance nightmare. And Apple's stuff, again, as great as it is trying to do the same thing of just drawing all of those different points of interest at the same value. So, like, you've got many hundreds of thousands of data points trying to be shown on potentially very small devices. So how do we then look at solving it? In the true senior engineer response, well, it depends. Now, the reason I say this is all of your data is going to be very specific to the domain at which you're working in. So you have to make trade-offs of what points can I draw, what points can't I draw. So you just need to go and ask yourself, okay, how much of this data do I really need to be showing at this one point in time? So if there's hasn't been a significant change in your values from one point to another, can you just get rid of them? Can you because it's a representation, can you just throw out 4 out of the 5 bits of data? Look at your data, understand your domain, and go, okay, what can I show? Another option is, do I only show one of those graphs for my domain? Does that actually make sense, or do I need to be showing them all at the one time? For my approach, looking at your significant changes is going to give you your best result. So here's what I'm doing. This is some of the calculations that I'm working with for the data sets. So getting a whole heap of very detailed data and going, okay, if I'm looking at, say, distance or looking at time on the x-axis, how much of a difference between those values has actually happened? And does that, do I then need to draw this next point, or can I just throw it away and wait until another significant change has happened? So here, that last of the guard statements is what is showing the difference in the sensitivity. So that is, okay, have I progressed far enough in order to show this next point of data? Okay, so having done all of that, ended up with something that is pretty performant, pretty accurate, gives me a lot of interactivity and a great amount of detail. Throwing it all into the app because you like seeing pretty pictures, this is what I end up with. So here you've got your speed, it's toggleable between your distance and your time, so I can switch those out. Don't need to show both of them, just show the one, allow the user to change between them. It's interactive and all kinds of fun stuff. Awesome. Okay. I am going to give you all eyes a break. That is the end of my presentation. Thank you very much.
Well, anyone have any questions for Amy?
Did you want to switch it off the... Hey.
How does it go when you put something slightly more complex, like dual axes? Like you have the speed on one axis and the elevation on another axis, and have two lines across the maps?
Sorry, the question was, how does it go when you are wanting to present a single graph or chart, but have multiple data sets represented? So an example would be you're showing both speed and elevation on the one chart. It's the same approach as you're drawing your line mark and then your area graph. That's two separate bits of information being drawn. You can have, say, 2, 3, 4, however many different line marks there you want. You style them differently and you provide different symbol information if that's relevant as well. So yeah, handles it really well. Beautiful abstraction. Have a go. See what you can come up with.
Yeah, the charts look amazing. Is there any downfalls at the minute? Looks like it's a no-brainer, but has there been any shortcomings that you've come across?
Okay, so the question was, have there been any shortcomings, any downsides, any pitfalls to adopting Swift charts? Probably two that I would highlight is one, it would have been amazing if Apple had a magical solution to the performance issue. Yeah, that would have been really nice, but sadly, every bit of performance they ran into, I've also hit. It's very difficult to get around, so you look for other solutions with adjusting your data set to provide a similar representation, but something that is more appropriate for the screen you're displaying it on. The second one is, this is really good for the latest and greatest stuff. Not everyone updates on day 0. So in any usage, you will have to go, do we want to adopt this? How will users that aren't on the latest and greatest experience the app? Yeah, my solution is, make them update. But my usage numbers for this particular app aren't that stellar, so I have that luxury. Not everyone does.
Also for pie charts. Does anybody else have any other questions?
Hey, don't know how much you've gotten into Swift charts, but in your exploration, does it handle any kind of zoom functionality on charts at all? And if not, if you're going to have any plans?
So the question was, does it handle any zoom functionality, and do I have any plans to do that investigation or do the incorporation into my app? Being a Swift UI view, anything is possible. So you could stick it into a scroll view if you wanted some horizontal scrolling in there. When you do your chart overlays and your gestures, if you just put in a drag gesture or something else that'll give you a start and an end, that then gives you points that you can limit your data set to and potentially just only draw that or redraw that as required. So yeah, definitely lots of possibilities. Have I quite gotten to that bit of exploration yet? No. Anything from Slack?
No, lots of discussion for you or for your questions.
Yep, everyone's trolling. Yep. I've been around long enough. It's pretty much expected.
No problem there at the moment.
Cool.
But thank you very much, and we'll go there.
Thank you.